everyone, I'm Victoria, and together with my group mates, which consists of Nur Atiqah SYAHIRAH and Nur SYAHIRAH, we're presenting our answers for the PHY3306 assignment, which is an SCL module on operational amplifiers. Okay, so operational amplifiers is an integrated circuit that has the ability to amplify weak electric signals. In our later part of the module, where we have calculations going on, and if you compare the input voltage values and output voltage values, whether or not they were given in the questions or they are calculated answers. Okay, but anyways, if you compare the input voltage values and the output voltage values, you will get a huge difference. So in other words, operational amplifiers is like a circuit that is able to provide extremely high gain amplification of the difference in voltages between the two inputs. Okay, in our daily life, where do we get operational amplifiers? We can see operational amplifiers, for example, in audio devices, in speakers, in PA system, etc. All right. Okay, so back to our module. I'll be presenting on activity 1, which is a crossword puzzle on operational amplifiers. Let's look at the words going across first. So for number 3, it's asking for the theoretical value of open loop gain. The answer would be infinite. An infinite gain only applies to an ideal operational amplifier. Next, the number of output terminal. Okay, referring back to our lecture slides. So this is a screenshot I got from our lecture slides. And if you look at this diagram here, which is a symbol of the operational amplifier, you get 2 inputs and 1 output. Okay, so the question is asking for the number of output terminals. And we have 1. So the answer is 1. Now next, the shape of the operational amplifier symbol. Okay, back to the diagram. So obviously it's a triangle. The answer is triangle. What's another name for operational amplifier? The answer will be op-amp. So op-amp is the short form of operational amplifier. Now let's look at the words going down. So number 1, what is the ratio between output over the input voltage? Referring back to our lecture slides, okay, so over here, we get V out over V in, which is also output voltage divided by input voltage. So this ratio is what we call the operational amplifier gain. So the answer is gain. Next, going down, number 2, what is the name of the negative terminal? Okay, so like I've mentioned before, we have 2 terminals. Okay, this is a screenshot I got from our textbook. So we have input 1, which is also called a non-inverting input, and input 2, which is called an inverting input. And we have to take note of the polarity of the terminals as well. So the question was asking for the negative terminal. So negative terminal, we call it an inverting input. So the answer is inverting. Yeah, inverting. If let's say the question is asking for a number of positive, if let's say the question is asking for the name of the positive terminal, the answer will be non-inverting. All right, number 4, the number of input terminals. So like I've mentioned before, a lot of times we have input 1 and input 2. 2 inputs. So that will be the answer, 2. Lastly, what is the connection between the output back to the input? Okay, this is a screenshot from our lecture slide as well, just to illustrate, right? So let's look here. Let's say this is the output terminal, and we have 2 input terminals, as mentioned a lot of times. Okay, so if let's say we want the connection that leads from the output terminal to the input terminal, so we have this here. This is called a feedback. So in this case, there's a resistor here. This resistor will be called a feedback resistor. So the answer is feedback. And this is the complete answer for activity 1. Thank you.
Hello, my name is Nur Atiqah binti Azmi with matrix number 205669. So I'm going to discuss for activity 2, operational amplifier configuration. So we need to complete the table below by giving the operational amplifier name and also the output formula. Okay, for the first configuration, so this is a summing amplifier, and the output formula is V output is equal to negative RF over R1 V1 plus RF over R2 V2 plus RF over R3 V3. So how do you get the output formula? Okay, so first of all, before we go into that, I want to discuss the characteristic of ideal op-amp. Okay, so for an ideal op-amp, the R input is infinite and the loop gain is also infinite, which is the value is extremely high. For R output is equal to 0, current input is equal to 0 because our input is infinity, so the current input will be equal to 0. So when the resistant input is equal to infinity, there will exist open circuits at both inputs. So therefore, both inputs current is equal to 0. All right. So this is the diagram for op-amp, operational amplifier. Okay. For summing amplifier is an op-amp circuit that can combine number of input signal to a signal output. Okay, in inverting amplifier, which is the negative terminal, there is only one voltage signal applied. So from this diagram, this can be modified into a summing amplifier. How? By connecting several input terminals in parallel to the existing terminals. Yeah, the existing input terminals. Okay, so according to this diagram, the non-inverting terminal, which is the positive terminal, is grounded. So the V here is equal to 0. So if we consider for an ideal op-amp, V at the inverting, the negative terminal, is also equal to 0. Remember, current at both inputs is equal to 0. So, so current at this junction, we call it summing junction, also equal to 0. Okay, so the current I here is equal to the sum of currents of input terminals. Okay, so equation-wise, you can see I is equal to I1, I2, I3, and so on. So put it in the form of V over R. V1 minus 0 over R1 plus V2 minus 0 over R2, V3 minus 0 over RT, and so on. So you will get this equation. Okay. So by applying KCL, the input current will pass through RF here. Okay, so I is equal to 0 minus V output over RF equal to negative V output equal to RF. So we have another equation. So we combine the first and the second equation. You will get and do a little bit of mathematics and you will get the V output formula. So this is how you get the V output formula for the summing amplifier. Okay, so for the next configuration, so this is a non-inverting amplifier. And the output formula is V output is equal to 1 plus RF over R1 V input. Okay, so how do we get this output formula? So first we need to know what non-inverting amplifier is. Non-inverting amplifier is basically an op-amp circuit with an output voltage that is in phase with the input voltage. So if this is the signal applied, so this will be the output signal, the output signal. This is for non-inverting. So here I put also for inverting, which is we will discuss later. For non-inverting, if this is the signal applied, the signal output will be 180 degree out of phase. Okay, so according to if we consider an ideal op-amp, there are two rules for any operational amplifier, which is the current rule, which is no current flows into the inputs of op-amp. So both current at both the input terminals will equal to 0. Okay, and the voltage rule, which is the output of op-amp attempts to ensure that the voltage difference between two inputs is 0. Or in another way, V1 is equal to V2. Okay, so this is the non-inverting op-amp circuit. Okay, so according to voltage rule, V positive, which is the terminal V at positive terminal, is equal to V at the negative terminal, which is in this case equal to V input. Okay, so current I at R1 will be equal to V input over R1. So according to current rule, we know that the current at both input terminal will be equal to 0. So in true sense, I only pass through RF. Okay, so the V output will be V input plus V input R1 RF. Okay, V equal to IR. Okay, equal to 1. You factorize V in, and then you will get the final V output is equal to 1 plus RF over R1 V input. So this is how you obtain the output formula for non-inverting amplifier. Okay, moving on to the next configuration. So this is the differential amplifier. So the output formula is V output equal to RF over R input multiplied by the difference between two inputs terminal, V2 minus V1. Okay, so differential amplifier or op-amp substrate is another name for differential amplifier. It's a type of electronic amplifier that amplifies the difference between two input voltage but suppresses any voltage common to the two inputs. Differential amplifier is actually an analog circuit with two inputs, V1 and V2, and one output, which is V output, and in which the output is ideally proportional to the difference between the two voltage. So we will discuss this later. So by combining the inverting and non-inverting op-amp configuration, we can achieve or we can design the differential amplifier. Okay. So this is a diagram for op-amp. If we consider V1 acting alone and we ground V2, say if we ground V2 like that, okay, so V2 equal to 0, so you will get an inverting configuration, okay, and vice versa. If we let V2 acting alone and we will get a non-inverting configuration. Okay, so what we do is that we consider one voltage at a time and the remaining voltage will be equal to 0. Okay, so let's say if V2 equal to 0, so the V output will be equal to V1, V output 1 equal to V1 negative RF over R1. Okay, so if V1 equal to 0, the V output 2 will be equal to V2 1 plus RF over R1. So if V1 and V2 acting simultaneously, so you will get V output is equal to V output 1 and V output 2 plus V output 2. So you sub in all the values, you will get this. Okay, so as we can observe, the gain that applied to both input here is different. So suppose we want V output to be A multiplied by the difference between two voltage input, V2 minus V1. So we need to make sure that the gain is equal. Okay, and assuming a gain at both input is RF over R1, so we can use the configuration as differential amplifier where the V output is equal to A, is equal to the difference between two voltage input multiplied by a gain factor A. Okay, so how do we achieve this equal gain? Okay, so recall back this equation, V output equal to negative RF over R1 V1 plus 1 plus RF over R1 V2. Okay, so the second term here, instead of 1 plus RF over R1, we want it in the term of RF over R1, this term. What we do here is actually we supplied V2 with a voltage divider circuit. Okay, so at this point here, let's say we call it V plus, should be like that. V plus, okay, so V plus here will be equal to RF over R1 plus RF V multiplied by V2. Okay, so we get the first equation here. So we know that the V output, because of the V2 here, V output be equal to 1 plus RF over R1 V plus, right? So we get another equation. So we substitute 1 into 2. We will get the V output is equal to 1 plus RF over R1 multiplied by RF over R1 plus RF V2. So if we simplify all of this, we will get in the terms of RF over R1 V2, just like we wanted before. Okay, so now consider both voltage source simultaneously. We just put the term that we achieved just now. So V output is equal to negative RF over R1 V1 plus RF over R1 V2. So just factorize the RF over R1. So finally we get the the output formula, which is the difference between two voltage input multiplied by a gain factor of RF divided by R1. So this is how you get the V output formula for a differential amplifier. Okay, next configuration. This is an inverting op-amp. Okay, the output formula is negative RF over R input multiplied by V input. Okay, so for inverting op-amp, inverting op-amp is actually operational amplifier op-amp circuit with an output voltage that changes in the opposite direction as the input voltage. Just like we discussed before, it is out of phase by 180 degrees. So if this is the signal applied, this will be the signal output. Okay, so we all know the theoretical value of an open loop gain is infinite, which is, in other words, extremely high. Therefore, we can lose some of this high gain by connecting a suitable resistor across the amplifier from the output terminal back to the inverting input terminal to reduce and control the overall gain of amplifier. Because what happened when the open loop gain where the value is really high is that both the amplifier will be unstable and the V output will be saturated. So we want it to be reduced and controlled. We put a suitable resistor across the amplifier from the output terminal back to the inverting input terminal. Okay, so this effect is called negative feedback. So this negative feedback will cause closed loop gain. Okay, so now if we recall the two golden rules in every op-amp is that no current flow in both input terminals, and V1 is always equal to V2. So from these rules, we can derive the equation for calculating the closed loop gain of an inverting op-amp. So by calculating the closed loop gain, we can obtain the output formula as well. Okay, so this is an inverting op-amp. Okay, as we can see here, the current I flows to resistor. So I here, it will be equal to V input negative minus V output over R input plus RF. Okay, so I is equal to V input minus V2 over R input, which is equal to V2 minus V output over RF. So do a little bit of mathematics here. Just divide this two, and then because we want the V input over R input to be the subject. Okay, so when you get this, just put V input over R input as a subject. You factorize V2, you will get V2 equal to V2 1 over R input plus 1 over RF minus V output over RF. So as we know, I is equal to V input minus 0 over R input equal to 0 minus V output over RF. So RF over R input will be equal to 0 minus V output over V input minus 0. Okay, so we can obtain the closed loop gain, which is equal to V output over V input equal to negative RF over R input. Okay, so to gain the output formula, we are to obtain the output formula, we just put the V input over here. So you will get negative RF over R input multiplied by V input. So this is how you obtain the V output formula for inverting op-amp. Okay, this is the last configuration. So this is a voltage follower or buffer. The output formula is V output equal to V input. Okay, so voltage follower is an op-amp circuit whose output voltage straight away follows the input voltage. It's used as a buffer amplifier, isolation amplifier, unity gain amplifier as the output follows the input. So there's no alternation or no amplification, but only buffering due to its high input impedance and low, very high input impedance and very low output impedance. So it does not amplify input signal, and it has a voltage gain of 1. So this is actually the configuration. If we apply a 10 volt input signal, so you will get the 10 volt output signal. So the output formula is equal to V input equal to V output. Okay, so for question number 1, calculate the output voltage of an op-amp summing amplifier for the following sets of voltages and resistor. Use RF equal to 1 mega ohm in all cases. So now we have the value of V1, V2, V3 here, V1, V2, V3. Okay, so we also have the value for all the resistors. All we need to do is substitute those values in the output formula of a summing amplifier. Okay, so this is the output formula, just like we did before. So just sub in all the values. So you will get the V output is equal to negative 7 volt. Okay, for the next second question, what should be the input? Okay, this one, what should be the input if the output required from the configuration is 15 volt? So given output, we want the input. So we can see from this configuration, this is an inverting configuration. So just use the formula of output formula of an inverting amplifier and op-amp. So you just substitute all the given values, you will get the V input is equal to negative 1.5 volt. So that is all for activity 2. Thank you.
Assalamualaikum and hi everyone. My name is SYAHIRAH binti Sharon Nizam with matric number 206666. Today I will explain about activity 3, which is cascade amplifier. Okay, cascade amplifier. Most of the time, few amplifier need to be connected to perform a required function. This combination of amplifier is known as cascade amplifier. To solve for cascade amplifier, we need to do it step by step from one amplifier to another amplifier. Okay, for the question 1, calculate the voltage, the output voltage if V1 equal to V2 equal to 700 millivolt. After we jot down the important point at the question, we need to know the type of amplifier. Okay, for the first one is inverting amplifier. Inverting amplifier, I know the inverting amplifier voltage input is connected with R input and RF. So this is the R input, R, and this is RF. So, okay, this is inverting, and okay, this first part, this is second part. The second part is, okay, which type? The type is for summing amplifier. How I know this is summing amplifier? Because we have R1 and R2. after we know the type of amplifier, we can solve the question. So the question asks to get the voltage output. So I solve the question with I divide this is amplifier 1 and amplifier 2. For amplifier 1 is inverting. So inverting, we have formula voltage output equal to negative RF times V input over R input. So after we know the formula for inverting, just plug in the value, which is RF is this is RF. Okay, and this is the R in. RF is a negative 500 kilo ohm times 700 millivolts. Okay, voltage input is given at the question. So voltage input is 700 millivolts over R input is this R input is 25 kilo ohm. So after plug in the value, calculate, we get the voltage output for the part 1, for the amplifier 1 is negative 1.4 volts. Okay, for the amplifier 2 is summing. So the formula for summing amplifier, V output equal to negative RF times V1 over R1 plus RF times V2 over R2. So I factorize this formula. So negative RF times V1 over R1 plus V2 over R2. So negative RF is 500 kilo ohm times V1. Okay, how I used to know the V1? Okay, voltage, the value for voltage output. After we get the voltage output at the amplifier 1, the voltage output use this voltage output become the voltage output become V1. Voltage output become V1. So V1, this V1, the value for V1, we just take from voltage output at the inverting part. So negative 1.4 volt over 100 kilo ohm plus V2 we get from the question. The question tell us the value for V2 is 700 millivolts over 50 kilo ohm. So after calculate the value, we get the 0 volt. So this question give us voltage output. So voltage output is equal to 10 volt. So after we read and underline the important point at the question, we should know the type of amplifier. Okay, for the first one is inverting. This is inverting because voltage input is connected with RN and RF. So this is first amplifier 1, amplifier 2, and amplifier 3. Okay, for the amplifier 3, it's different because this is non-inverting because the voltage input and the resistor input and RF is connected with ground. This is my calculation. Okay, we saw from the right hand side. Okay, we know that inverting formula voltage output is equal negative RF times V input over R input. So just plug in the value. We know that a voltage output for the voltage output for okay, kita focus on amplifier 1, which is inverting kan. For the red part, uh, voltage output is so replace voltage output with 10.08 volts, and the RF value is 100 kilovolt, and voltage input which is we need to find it. R input is 5 kilo ohm. So plug in the value. Voltage input is negative 0.504 volt. Okay. We move on for we move to the second part, amplifier 2, which is inverting type. Okay. I need to explain you guys the important thing. After we get the voltage input at amplifier 1 is equal to voltage output for the amplifier 2. Okay, so we have the value for V input. But for the part 2, voltage input 1 is equal to voltage output part 2, amplifier 2. Okay. Okay, hope you guys can understand. Okay, so the amplifier 2 is also inverting. So plug in the value, negative 0.504 volts equal to negative RF value. Okay, for RF value, part 1 is 5 kilo ohm. For R in for amplifier 2 is 4 kilo ohm. So we get the voltage input is 0.504 volts. Okay, we move on to the amplifier 3, which is non-inverting. Non-inverting, the formula is voltage output equal to 1 plus RF over R1 times V input. So we know that voltage input to amplifier 2 is equal to voltage output V3. Just take the value voltage output at just use voltage input amplifier 2 for the voltage output amplifier 3. Okay, so voltage output, we know voltage output equal to voltage input amplifier 2. So 0.504 volt equal to 1 plus, okay, RF. RF for the part 3 is 10 kilo ohm. For the R in for the amplifier 3 is 5 kilo ohm. So just plug in the value 0.8 and rearrange. We get the voltage input for the amplifier 3 and total. The total for the voltage input is 0.168 volt. Okay, we move on to the question 3. Calculate the output for the configuration. So first I label the amplifier 1, amplifier 2, amplifier 3. So after that, we need to know the type of amplifier. So the first one is non-inverting because the R input and RF is connected with ground. So for the amplifier 2 is voltage follower because the negative is connected. We have this diagram. The circuit is connected. For negative is connected at the voltage output. So this called voltage follower or buffer. So, and for part 3 is when we have this kind of diagram, which is have resistor 1 and resistor 2. So this diagram, this amplifier is called the summing amplifier, the summing type. So okay, the calculation for, we settle up for the part 1, which is non-inverting. We use the formula voltage output equal to 1 plus RF over R1 times voltage input. So 1 plus, okay, RF for the part 1 is 400 kilo ohm. R in is 20 kilo ohm. So the voltage input is 0.1. So plug in the value 1 plus 400 kilo ohm over 20 kilo ohm times 0.1 volts. We get the voltage output for the amplifier 1 is 0.1 volt. Okay, for the amplifier 2, the second part is, we know the amplifier is, this amplifier is voltage follower, which is buffer. Buffer formula is very simple, very easy to memorize, because voltage input equal to voltage output. So voltage input is, okay, voltage input is this 0.1 volt. So we simply know the voltage output for amplifier 2, which is 0.1 volt. So to get the voltage output at the end, we need to solve the amplifier 3. So how we know the voltage 1 and voltage 2 value? So voltage 1 and voltage 2 value is equal to voltage 1. This part, voltage 1 is equal to voltage output at the amplifier 1, and voltage 2 okay, so voltage 1, see, this is voltage 1, voltage 2. So after we get the voltage output at V1, so voltage output at V1 is equal, voltage output at amplifier 1 is equal to voltage V1, and the voltage output at the amplifier 2 is equal to V2. So just use the just use the formula summing, which is voltage output equal to negative RF times V1 over R1 plus RF times V2 over R2. So I factorize this formula, so make it easy. Negative RF times V1 over R1 plus V2 over R2. So okay, for the summing, the RF, okay, part 3, this for the RF. This is RF for the amplifier 3. This is RF. This is R1. This is R1 value. This is R2 value. So just plug in the value. Negative 100 kilo ohm times, we know that the voltage output amplifier 1 is equal to V1, so 21 volt over 20 kilo ohm plus voltage output at amplifier 2 is equal to V2, so V2 is 0.1 over 10 kilo ohm. So calculate, we get the final output, voltage output is equal to negative 11.5 volts. That's all from me. Thank you.